Okay, sorry about that. My computer cut out in the middle of that problem and I just kept on talking. So I recopied the problem. I'm going to work it again because I was almost done with the whole problem when I realized it. So here we go. These were the bits of information that they gave you in the problem. They specifically asked you to find compounded interest. And whenever you see the word compounded, this is the formula for compounded interest. Compounded means you're getting paid interest upon the money that you have at the end of each year. And you're paid on a certain schedule. And these are called compounding periods. Like sometimes you'll have an agreement with the bank where they're going to pay you your compounded interest semi-annually. And that word semi-annually, that phrase means that you're going to be paid twice a year. Sometimes they'll say that they're going to pay you quarterly, and then that would mean that you're going to be paid 4 times a year. Sometimes they're going to pay you monthly, then you would be paid 12 times a year. Anyway, the number of times that you are paid per year is called your compounding periods. And in this formula here, it represents N. The amount that you're investing, that's called the principal. That's that value that goes right there. The rate needs to be a decimal. And I think that one's pretty obvious that it stands for R for rate. The accumulated amount is what ends up in your account after you get paid interest. So the accumulated amount is this A for accumulated. And then T, pretty obvious, is time in years. Notice that the N value, how many times you're going to be paid throughout the year, this would be semi-annually. And sometimes they just give you that word and then you have to know from the word how many times you're going to be paid, what value to use for N, but here they just gave it to you. And so notice that N value appears twice. Okay, so we just start basically plugging in, but where it hooks into this section is that in order to solve for this T, which is in the exponential position, you're going to need logs, because that was one of the main functions of logs. Like in the last 5 or 6 problems that I just did before I got to this word problem, I was taking the log of each side in some of the problems that I did. Okay, so let's plug in everything where it belongs. Don't forget to take the rate and turn it into a true decimal. All these word problems require that your percentages be written as decimal. So you just slide this 2 places to the left. That's how you're going to be using it in the problem. This is very calculator based. So the accumulated amount is 16,000. That's what it grows into after your interest. What you started with is called your principal. 14,500, and then it's 1 plus the rate, 0.0625, divided by the number of compounding periods, and then it's 2 again for the N. T we don't know, but we will be solving for it, and then just begin putting this into your calculator to at least get this more simplified, and then we'll go from there. So it's 14,500, and if you put this in your calculator and just get one number, 0.0625 divided by 2, and then add 1, and you get 1.03125. Raised to a power of 2t. So this is what you're looking at this point. 16,000. And then 14,500. Now, what you want to do before you take the log of each side, there's no logs in this problem right now. So I think these were more like in the middle of the section where you were taking the log of each side. You want to isolate this power term. So in other words, we could at least get rid of this before we go taking the log of each side. So divide each side by 14,500. Let me get my calculator working. And this is going to be 1.10345. I'm going to hold on to about 5 decimals just for better accuracy towards the end of the problem. 10345. Okay, that cancels there. And then you would have 1.03125 raised to a power of 2t, and that's when you go in and you take the log of each side. I'm going to use natural logs. You actually have a choice in this case. You can do regular log or natural log. I'm going to use natural log. I mean, you definitely want to use natural log when there's ease in the problem, but otherwise you have a choice. And if I'm doing natural log on this side, I will also do it on this side. Okay, so let's see. At that point, you're taking the log of this expression, which has an argument and a power, and so you can use the power rule for logs, which means you can do this. You can take the 2t, and it becomes the coefficient of this term right here. And then you have ln over here, 1.10345. That look a little bit more legible. Okay, then to continue, you want to try and isolate for t, so begin getting everything away from the t. Now you could actually get rid of both of these things that are hovering around the t so that you can isolate t. You can divide off that 2 because it is a multiplier, so getting rid of it requires division. This is a multiplier, so dividing it away will get rid of that as well, and you can get rid of both things at one time. Remember, whatever you do to one side, you must also do to the other side. If you're hearing snoring in the background, those are my Boston Terriers. They love to take a nap and snore right where I'm making a movie. Okay, so this is going to cancel. That's going to cancel. You'll be leaving the t by itself. This definitely wasn't going to fit on the worksheet. That's why I knew I had to copy it over here. And then let's go ahead and put that in the calculator. Long problem. All right. Okay, so let's see. ln of 1.10345. I'll just show it to you in pieces. 0.09844. That was my top. And then this times this. Whoops, I switched over to logs. Let me fix all those. I mean, it's just either all logs or all ln's. And since I did start it with ln's, let's just make sure being consistent throughout the whole problem. And you do have the choice at the beginning to use whichever one you want, but then be consistent. Don't switch in the middle of the problem like I just did. Okay, so nothing lost. Just those cancel, and this same expression is over here, so now I'm about to get that right now. So 2 times ln of 1.03125. And this is 0.06154. And then you're almost there. 0.09844 divided by 0.06154. And I got 1.60 years, because t is time in years. And let's see what they asked us to round off to here. Okay, so do not round until the final answer. And then when you do round, you're going to round to 1 decimal place is what it said. So 1.6 is what you would get for the answer. I don't think they'll mark it wrong for that, but that's how many years it took. Okay, last and final problem, number 29. They give you a different formula. And the reason that you're using that formula is because it is not compounded interest, but continuous. It's compounded interest, but it's compounding continuously. So instead of having predetermined points at which the bank comes in and pays you interest, like again, if they said semi-annually, semi-annually means twice a year, so the end value would be 2. If they said quarterly, the end value would be 4. But when they're paying you continuously, there is no end value because they're not paying you in predetermined intervals. They're just continuously paying you compounded interest. So if you see the word continuous in the problem, you are to use the continuous compounding formula. And that would be, I'm going to do it here because I didn't leave myself enough room on the worksheet. So I printed this right from my math lab, and they put very little space between the problems. Okay, so if you look in that table right there, the amount invested, that is your p-value, that's 6,000. And then E is just it's a constant. We're going to raise it up to a power where the rate is multiplied by the time, although we're looking for time. The rate that you have here is 13%. So that's going to be as a decimal, 0.13. Remember, these rates need to be used as a decimal. So it's rate times time. The final amount, it says double the amount invested. So for this accumulated amount, you want to double this. So therefore, you should have 12,000. Instead of 6,000, 12,000. Okay, then to continue with this problem, you're going to divide this by 6,000. So you want to try and get this exponential expression by itself before you take the log of each side. So this will be gone on this side. You'll have e to the 0.13t on the right, and over here you'll have 2. Then you're going to take the ln of both sides. ln is very good in this case because you'll be able to use the inverse property on one of the sides, namely this side right here. ln's have a base of e, and when the augment matches the base, takes the word log with it, that's the inverse property, so down comes that 0.13t. So it's nice when you can use that. And then over here, you're going to get this value from your calculator, and let's see how they want you to give the final answer. It says do not round until the final answer, then round to 1 decimal place. So let's go ahead and go in our calculator and get that ln of 2. And that is 0.69. I mean, I'm reporting these numbers to you, but 0.69315. And then divided by 0.13. And I got 5.3 years. That's after dividing by 0.13 on both sides. Okay, so 5.3 is the answer, and that concludes section 4.4. So only one section left.